Okay, so to start this lesson, we are going to talk about something that is actually somewhat familiar from the past for you guys. First off, the question is, what is a function? And so if you notice, it does say in your notes to recall, I mean, something you've learned in the past. So there are a couple different ways that you can identify whether or not something is a function. And so the first thing that you want to look at is just a description. And the description of that is that each value in the domain, has only one value in the range. One value in the range. So that is kind of like the definition of a function, is that each value in the domain has only one value in the range. So what does that mean? So when you're looking at an ordered pair, what that means is that the x's cannot be repeated. So no x is repeated. And again, that's within ordered pairs. Okay. If you are looking at what's called like mapping, and so you may have seen this sometimes in the past, or you may see it sometime in the future. If these are your x values and your y values, each x only goes to one y. Okay, so no matter what you have there, it only goes to one y, as opposed to, but not, if you have something where you have your x's and your y's, and the x goes here and it could go here. So the same x goes to a different y value. That's called mapping notation. The other way is if you have a graph, you can do what's called the vertical line test, and I'm guessing that many of you guys remember vertical line test. So those are the three ways to kind of think about that. Again, this first thing is just a definition. The other three is one with respect to your ordered pairs, one with your mapping, and then of course the last one in terms of what does it mean for a graph. So as far as some fill-ins are concerned, finding the domain and range graphically. Your domain is just going to be find all the x values that are included in the graph. The first thing that you want to look for is you want to look for any x values where the graph is undefined. Okay. In terms of your range are all of your y values that are included in the graph, and you want to look for any y values where the graph is undefined. You also want to look for what's called the extrema. You guys have seen that before already, meaning your maxes and mins. Okay, so you want to look for any extrema of both functions. Okay, so just a quick recap. Your domain are your x values, your range are your y values. That's kind of the short way to think about this. So when you look below at the next thing, within your graphs, you have an open dot. If you see an open dot, the point on the graph that is left open just means that the graph does not include that value. Whereas if it's a closed dot, it means that it is included. So if it's a closed dot, it just means that the graph does include that value. Okay, and that's something you guys have seen before when you guys have graph number lines and inequalities there. In terms of dots at the end of the graph, okay, the use of a dot, whether it's open or closed, at the extreme left and right points of the graph, indicates that the graph does not extend beyond those points. Okay, so let's take a look at an example and kind of put this into practice. So what we want to look at is we want to use the graph to find the following things. The first thing is your domain. Okay, so again, you're going to read left to right, and you're going to think about what points are covered left to right there. Well, as you go to the left, -1 is included, and then as you read to the right, you have this point right here that is no longer included. So you have -1 to +4, and this is the other piece to keep in mind. We've talked about interval notation in the past. With your interval notation, what you need to do is if it's a closed dot, you have the square bracket. If it's an open dot, you have the parentheses. So this is the interval notation to represent your domain goes from -1 inclusive to +4. Where it says the function values at f of -1 and f of +2. All you're going to do is look at your -1 value, figure out what's that value, your y value at that point, which in this case, your y value is -5. And then you're going to do the same thing for f of positive 2. And again, your y value at that point is a positive 4. Notice for part C, it's asking you to do the range. So now instead of left to right, you're going bottom to top or up and down. It does include the -5. So again, we're going to have that bracket. That's where bracket. And it does include 4. It goes from -5 all the way to positive 4. Notice the order of those do matter. You're going to start with the smallest number first and the largest number second. So that indicates it's going from -5 to positive 4, and it includes both of those things. Okay, so now when we look at this next example, all right, you've got the domain of f. Again, you're going to read left to right. Now, one thing that is omitted on this screen, those should have arrows here. I know it doesn't. That actually changes your answer a little bit for part A. Your domain, as you read left to right, if you were to extend this picture forever, it keeps going left and right forever. And so your domain, it's going to go from -infinity to positive infinity. Now, the reason those are parentheses, again, you're never going to actually reach infinity, so it's not included. So you do have those parentheses there. Your function values of -1 and positive 2. This actually is a little bit of a typo. This should actually be f of -3 and then also positive 3. So just go ahead and fix those on your notes. F of -3, again, you're going to take and look at your values. At -3, your y value appears to be -6. However, if you look here, you have an open circle. That open circle indicates that at that point, it is actually undefined. If it was a closed circle, your answer would be -6. And then you have f of positive 3. And so now when you look here, you do have that -6 value because this one is a closed dot. Your range, again, you're thinking top to bottom. So if you look down below, this actually extends forever down. So your range is going to be -infinity. But as you go up, it's going to stop at this y value of 3. It is included since that circle is a closed circle, or that dot is a closed dot. So you're going to have the bracket there. Again, it's never going to reach infinity. So you're going to have that parenthesis there. Okay? Moving on to the next thing, finding your domain and range algebraically. The way that you want to go about doing this is you want to solve the equations for your x values that don't work. Okay, so I'm going to fill that in. Your x values there we go, that do not work, or that don't work. And what you want to do then is you want to look for the highest and lowest values that y will reach. So look for the highest and lowest values that y will reach. Okay, so when we look at your domain, okay, notice here, since this is the square root of a number, what that tells us is your square root cannot be negative. So the square root itself has to be greater than or equal to 0. Okay, we're not going to worry about imaginary numbers because in graph, you don't graph imaginary numbers. So that tells us underneath here, that radical has to be greater than or equal to 0. Okay, so the greater than or equal to 0 is because it's a radical. The x minus 4 is because that's what's underneath the radical. And then we're going to solve. So we have x is greater than or equal to positive 4. So then if we think about our interval notation, that means that your domain, your 4 is included, and because it's greater than, it's going all the way to infinity. And again, you have a parenthesis whenever you have infinity. And then you want to think about the highest and lowest values that y will reach. So in other words, you want to think about the square root of something. Okay, this is, I'm going to put kind of a thought bubble here so you can kind of, I'm going to ignore that for just a minute. I'm going to forget that little message. So this is my kind of thought bubble. I want to think about the square root of something equal to y. It doesn't matter what that something is. The square root, the lowest number that that's going to be is 0. Okay, because again, the square root of 0 is 0. The square root of a positive number is a positive number. You don't have the square root of a negative number. So when you think about that range, you've got 0 to infinity. Another way to think about this is if you think about your 12 basic functions that you worked with the other day, your function or your graph looks something like this. Your range starts at 0 and goes to infinity. It keeps getting larger, even though it's getting larger at a slower rate. Okay, so then when we look at the middle term here, for the middle example, same exact concept. Your square root cannot be negative, so it has to be greater than or equal to 0, and the thing underneath the square root is x minus 1. You're going to solve, so x is greater than or equal to 1, so your domain is going to be 1 to infinity, and your range, again, because it's that square root, the same thing, it's only going to get as low as 0, but it is going to get bigger without bound. Okay? And then the same thing for the last one. So if you haven't yet, go ahead and try that out. Just click pause real quick on your video, and then you can go ahead and practice that one for yourself. Okay, so it's the same concept, x minus 9, greater than or equal to 0, because again, we cannot have a negative in the radical. So x is greater than or equal to 9. Your domain is going to start at 9 and go forever to infinity. And then your range, again, because we're dealing with the square root, is going to go 0 to positive infinity also. Okay? The other thing that we want to touch on today is increasing versus decreasing. So a function is increasing on an interval for any x sub 1 and x sub 2 when x sub 1 less than x sub 2 implies that the y values at those points also grow. So this is how it's like worded in books. And I'm going to do the same thing for the next couple, and then I'm going to talk about what that means, just kind of logically, because I think if we think through this logically, it makes a lot more sense than dealing with all of these math terms, to be honest. So I'm just going to fill these in. Okay, so go ahead and just fill those in with me. And then a function is constant. So it's not increasing or decreasing, it's constant. For an x sub 1, x sub 2 in the interval where your values are going to be. So let me just talk through this real quick. So those are your fillings. But in terms of what this means, the best way I can do it is read left to right. Okay, so as you read left to right here, this value is going down. So you're going downhill. That's why it's decreasing. As opposed to over here, as you read left to right, your value is increasing. So therefore, that's the interval in which it's increasing. As you read left to right, if it's not increasing or decreasing, it's remaining constant. That's kind of the general description of all of this stuff here, okay? That if you think about it, it's as you read left to right, if it's getting smaller, it's decreasing. As you read left to right, if it's staying the same, it's constant. As you read left to right, if it's growing, it is increasing. Okay, so what we're going to look at is it says determine the open intervals. So we've got this word open intervals, we'll talk about that, on which each function is increasing, decreasing, or constant. So as you look at letter A here, as you read left to right, this graph is always growing. Now, I will be honest, in the middle here, it's not growing very quickly, but it is still growing. So your increasing interval is just going to be the whole graph. It's going to be negative infinity to positive infinity. And again, infinities have parentheses. This one, part B, as you read left to right, it's growing until you get to that point. At that point, it's going to switch. So you're increasing from negative infinity to, and then you're going to look at your x value for this. So at negative 1, it switches. Now notice since it does say open intervals, that means that you're going to be using parentheses because at that point, it's not that that point is technically included. So you are going to use open parentheses. At that point, you're going to switch, and now it's decreasing until you get to that point. So I'm going to leave a little gap here. And as I read left to right, so that is going to be negative 1 to positive 1, again, parentheses. And then again, it switches back to increasing. So from 1 to infinity, it goes back to increasing. All right. The last one here, as you read left to right, here, this is increasing until you get to this point. So it's, you're increasing, it's going to be negative infinity to 0. And again, since we're talking open intervals, it's a parentheses. It's going to then switch and become constant from negative, excuse me, not negative, from 0 until 2. Again, we're looking at those y values. And then it's going to start decreasing again from 2 to infinity. Okay? All right, one more thing, I believe. Yes. So notice it says using a graphing utility to approximate the relative minimum, relative maximum of the functions, and then determine the open intervals on which each function is increasing, decreasing, or constant. Okay, so here's the key. So using a graphing utility, you can use Desmos or you can use your graphing calculator. I have no preference. But with this, what you're going to see, and I'm just going to draw a general shape of this graph, okay? I'm not going to make it super precise. So if you graph it and you're not seeing that, just be aware of this. It's going to look something like, and actually I'm not even going to do a coordinate plane because I don't want to confuse anybody, but it's going to look something like this, okay? So your relative maximum and minimum are going to be those points right there, okay? So your minimum, if you use your graphing calculator and you were to calculate that, and we did this already, so hopefully you remember how to do it. If not, be sure to ask, is the point that you see here, okay? Again, you're going to do that either on Desmos or using your graphing calculator. Your max, actually, yeah, your max, we'll talk through that first before we talk about increasing and decreasing, is going to be 0.577. Again, these are rounded values, 0.385. So then as you're looking at this, again, what we're going to be looking at is as you read left to right, okay, it's decreasing up until that point. So the decrease is going to be negative infinity until that minimum point. And that minimum value, again, we're talking x values, that minimum value is negative 0.577. And then it's going to switch to be increasing from that minimum to that maximum. So again, we're going to have a negative 0.5772, and then that x value of that point is going to be 0.577, so the positive version of that. Okay, and then again, as you look, it switches as you go back down from that point. So we're going to decrease, and I'm going to throw this other value right here, but it's going to be 0.577 positive infinity. So as you're looking at increasing, decreasing values, you're always using your x values. All right, the last thing, what I'm going to have you do is just, again, pause the video. I'm going to go ahead and give you guys the answers, but pause it first, try it out, your max and mins, increasing, decreasing, and let's see what we come up with. Okay, so as I'm writing here, make sure you're checking your values, make sure that you are getting the same exact answers. If not, obviously ask. This is a lot of just using your calculator and knowing how to write these intervals. The concept itself maybe isn't the hardest, but sometimes knowing what goes where in terms of writing your answers, sometimes it's a little confusing. So again, double check your answers. As always, if you guys have questions, ask. We'll continue these notes in another video, but I just want to make sure you guys have an opportunity to ask whatever it is you need to ask.